Right, good morning, students. I welcome you back again to this class. The year 9 students, we are tackling mathematics from where we stopped last time. I remember we had done gradients and equations of straight lines last time, and we stopped at finding equations of straight lines. Today, if I can remind you what we did last time in finding equations of straight lines, equations of straight lines. We said there are two ways of finding equations of straight lines. So number one, given 2 points, and number two, given a point and the gradient. There are two ways of finding the equations of straight lines in the form of y is equals to mx plus c. Number one, we said given 2 points, and I exploited last time in the last class. We worked out examples and questions on how to find equations of straight lines given 2 points. Today, I want just to go straight. When you're given a point and the gradient, how do we find the equation? Given a point and the gradient. How do we find the equation in the form of y is equals to mx plus c? Now, if you are provided with a point of that line, of that straight line, and its gradient, it is easy to get the equation, because we say, for instance, find an equation of straight line. Find an equation of straight line that passes through the point 2, 3, and has a gradient of 5. In this question, we have the point, that is, and we also have the gradient. So the point is 2, 3, and the gradient is 5. The point is 2, 3, and the gradient is 5. We are finding the equation in the form of y is equals to mx plus c. Last time I told you that points are written in coordinate form, starting with the value of x, followed by the value of y. Now, we have y, we have m, we have x. So we find the constant c, which is the y-intercept. We substitute those values that we have. So we have 3, which is y. We have m, which is 5. We have x, which is 2, plus c. Now, 5 times 2, that gives us 10. So 3 is equals to 10 plus c. Now, we take 10 the other side. Whenever it crosses the equal sign, the sign changes to the negative. So 3 minus 10 is equals to c. Our c is negative 7. Now, we said we have variables. Variables in the equation y is equals to mx plus c, where m and c are constants. Now, those are the constants that we need to insert in. In other words, we place the value of m and c. We replace them. So in the equation y is equals to mx plus c, whereby we have m and c, we change that. The equation is going to be y is equals to 5x minus c. And that is the equation that you are requested to find. Alternatively, given the point, which is 2, 3, and you have the gradient, m is 5. This another way you can use. We have the point and we have the gradient. Now, how do we find the equation? We let another point being x and y. Let another point be x. Let another point be x and y. Remember how we find our gradient. Gradient is change in y over change in x. Gradient is change in y over change in x, which is y2 minus y1 over x2 minus x1. Now, these are our 2 points. We start by naming them. We have 2 and 3. We have x and y. Remember this, we don't have. We are providing. Let's say the next point that makes that straight line is this one. So this is our x1 and this is our y1. This is our x2 and this is our y2. Now let's substitute that. Remember, gradient is already provided. Gradient is already given. So now we're going to say y. Let me go back. Sorry. Let me do this. Let this to be y2 and this is to be x2. Let this to be x1 and this is to be y1. So then we say gradient is y2 minus y1 over x2 minus x1, which is y minus 3. y2, which is y, y1, which is 3, divided by, we have x2, which is x, x2, which is x, and x1, which is 2, which is equivalent to the gradient which is already provided. Now, we can place over 1, meaning that 1 will help you to cross multiply. So we have y minus 3 over x minus 2 is equals to 5 over 1. Then when we cross multiply that, we're going to have 1 into y minus 3 is equals to 5 into x minus 2. Now let's open the bracket. We're going to open the bracket. Now that bracket we have inserted there is helping you to multiply so that you don't confuse. Now 1 times y, 1 times negative 3, we have 5 times x, then you also have 5 times negative 2, that gives us negative 10. Now, let's take this negative 3 the other side. Remember, whenever you're finding equation of straight line, ensure that your equations are written in the form of y is equals to mx plus c. So you're going to have y is equals to 5x minus 10 plus 3. I've told you that whenever you take negative 3, a value the other side, the negative sign changes to the positive. So minus 10 plus 3 gives us minus 7. So our equation is going to be y is equals to 5x minus 7. Now, if you compare the two, you find they are the same. If you compare the two, they are the same. Remember, we are not marking answers. We are not just marking answers. We mark your steps. Every step accounts. Every step accounts. There are 2 ways of finding the equation of straight line, as in when you are given the point and the gradient. Now, here, you know that the equation has to be written in the form of y is equals to mx plus c. The equation has to be in the form of y is equals to mx plus c. Sometimes we say the equation is in the form of ax plus by is plus c is equals to 0. This is another form. Right? If we can now substitute this value and make y the subject of the formula by taking all the other values the other side, we end up having y is equals to mx plus c. Now, we know we are provided with x and y, and we also provided with the gradient, which is m, that is 5. Substitute them and have to find the constant, which is the y-intercept. C is the y-intercept. C is the y-intercept. Once you have the y-intercept and you have the gradient, now you can substitute, because constant, they don't change. They remain to be constants. So it is negative 7 and the gradient being 5. This is the equation that you have been asked to find. Find the equation of a straight line. Alternatively, I said, if you have the point and you have the gradient, you let another point being x and y. Then use that formula of finding the gradient. We said, how do we find gradient? Gradient is change in y over change in x. Change in y over change in x. Our previous lesson I said a change is a difference between 2 points. So you cannot find a change if you don't have the 2 points. A change is a difference between the 2 points. You can't have the change if you have not been provided with the 2 points. Now, our 2 points are here. Now, change in the y coordinate is y2 minus y1. Change in the y coordinate is y2 minus y1. Change in the x coordinate is x2 minus x1. Now, we name our points. This one we have named as x2 and y2. This is our yx1 and y1. Then when we subtract that, when we substitute the value y minus 3, then x minus 2, x minus 2. So when you subtract this, then we say is equals to 5. Now we put over 1. We put it over 1. Now, why do I have to insert 1 here? So that it can help you as a student to know that we are going to close multiply. So it is 1 times the numerator, the denominator times the numerator times the denominator, close multiplication. So now, and then I go ahead having the brackets. Now these brackets will help you so that you multiply with everything inside the bracket. Now, these values we have, they become the coefficients to the brackets. So that 1 times y, 1 times 3. Now 5 times x gives us 5x, 5 times negative 2 gives us negative 10. Now, I need to put the like terms together by making the equation to be in the form of y is equals to mx plus c. Anytime you are finding, anytime you are finding the equation, you have to write the equation in the form of y is equals to mx plus c, unless you are being asked otherwise. Now, when you take this negative 3, the other side becomes a positive. Now, minus 10 plus 3, minus 10 plus 3, that is integers which you've done. So you get it is negative 7. Let's look at another example. Let us look at another example. Let's see. Let's go through another example so that the concept can sink. You get to understand this thing. And I'm telling you, my beloved student, that you are not supposed to give us only answers. Steps, you have to show us your steps. Question 2. Find the equation of a straight line that passes through the point 2, 1 and has a gradient of 6. It has a gradient of 6. Now we know that m is 6. In the solution, in your solution, m is provided to be 6 and the point is 2, 1. The equation we are finding should be in the form of y is equals to mx plus c. The equation that you are finding should be in the form of y is equals to mx plus c. Remember, we have m, we have x, and we have y. Let's substitute that. We are going to say y is 1. So 1 is equals to m is 6. So it is 6 times. Now x is 2 times 2 plus c. What are we trying to find here? We are finding the y-intercept, the constant c. Now after we have done that, we're going to have 1 is equals to 12 plus c. Now take 12 the other side. It is 1 minus 12 is equals to c. Our c is equals to negative 11. Now the equation is in the form of y is equals to mx plus c. Now that we have the constant, we replace them in the equation. So we change m and c because we have their values. Y is equals to 6x minus 11. 6x minus 11. That is the first method. The second method on the same equation, the second method on the same equation of the question that you have been asked to find, then we have the gradient, which is 6. We have the point, which is 2 and 1. So you let another point be x and y, right? Now, let's say this is our point 1A and this is our point B. Now, in point 1, we have 2, 1. In point 2, we have x and y. So let's name this to be x1 and this is to be y1. This is x2, this is y2. Now, we are using the method of finding the gradient. So we are going to equate the gradient because the gradient is already provided. Gradient is already provided. Then you say gradient is change in the y-axis over change in the x-axis, which means y2 minus y1 over x2 minus x1. That is equal to the gradient that you are finding, which is 6. Now, our y2 is y minus 1 over x, which is x2, which is x minus 2, is equal to 6 over 1. Some other times, the gradient can be a fraction. And then when it's a fraction, it becomes easy for you to close multiply. So now we're going to create the bracket. 1 into y minus 1 is equal to 6 into x minus 2. Now, we're going to say 1 times y minus 1 is equal to 6x minus 12. Now, we take negative 1 the other side. Y is equal to 6x minus 12 plus 1, meaning minus 12 plus 1 is negative 11. So y is equal to 6x minus 11. That is the question. Now, if you compare the two, you find that they are the same. So you can use this one if you're okay with it. Or you can use the other one. At the end of it, you'll have the same marks. What you have to take seriously is the steps that you are giving us. How you've worked out the problem until you've come to the answer. I've told you, most of the time, we don't mark answers. Answer can only have 1 mark, and they leave a lot of marks outside. So how you arrive at your answer, it is very, very important. At this point, I want to leave you with one question that you will work out when I'm done. Ensure that you get it right. Ensure that you get it right. Finding an equation of a straight line from the second point, which is when you are given a point and the gradient. So, my beloved student, this is your assignment. This is your assignment. This is your assignment. Assignment as long as far as this assignment, as far as this finding the gradient is concerned. Now, I will want you to find the equation of a straight line. Equation of a straight line with the gradient of a half and passes through the point and passes through the point 4 and 6 and passes through the point 4 and 6 and passes through the point 4 and 6. This is your assignment. I repeat, find an equation of a straight line. Find an equation of a straight line with the gradient of a half, 1 over 2, with the gradient of a half and passes through the point 4 and 6. Now, let's move to the next thing. Let's move to the next, whereby we'll be talking about how to state the gradient and the y-intercept. How to state the gradient and the y-intercept. Stating the gradient. And the y-intercept. Stating the gradient and the y-intercept. Now, for you to state the gradient, it means you must be given the equation of a straight line. A equation of a straight line must be given. The equation of a straight line must be provided. Must be provided in order to be in a position to give the gradient, to highlight the gradient and it's what? It is y-intercept. And it's y-intercept. Remember that question, for you to be in a position to state the gradient, the equation must be in the form of y is equals to mx plus c. Must be in the form of y is equals to mx plus c, where m is the gradient. M is the gradient and c is the y-intercept. Y-intercept. I remember at the beginning of this topic, I had mentioned about m and c. And in these two, I said these are constants. These are constants. These are constants that are in the equations. They don't change. Right. Now, y-intercept. Sometimes by calculations, not only stating, sometimes by calculations, how do you arrive at the y-intercept? I'm coming there shortly. Now, we say the equation must be in the form of y is equals to mx plus c. Now, state, example, state the gradient and the y-intercept from the following equations. Roman 1, we have y is equals to minus x plus 4. The first thing that you need to identify is the equation written in the form of y is equals to mx plus c. Is it written in the form of y is equals to mx plus c? And if it's not written in the form of y is equals to mx plus c, start by writing it in that form. In this one, you realize the equation is already in the form of y is equals to mx plus c, whereby we say the coefficient of x gives us the gradient. The coefficient of x gives us the gradient. And the coefficient of x is this value which is here. Now, m is -1. And the constant c is the y-intercept. So our y-intercept here is 4. And that is it. As easy as that. Now, in Roman 2, you may be given 2y plus 4x plus 6 is equal to 0. For instance, you have 2y plus 4x plus 6 is equal to 0. You realize that equation has not been written in the form of y is equals to mx plus c. Don't jump into conclusion and say m is equal to 4. and then say y-intercept is 6. That is wrong. The equation has not been written in the form of y is equals to mx plus c. So you start by writing this equation, which is 2y plus 4x plus 6 is equal to 0. Now, change it in the form of y is equals to mx plus c. How do you do that? Now, take these two, the other side. We're going to have 2y is equals to minus 4x minus 6. Then divide both sides by 2, by 2, by 2. Now, to remove the coefficient, because the point here is making y the subject of the formula. The point here is making y the subject of the formula, as in expressing y in terms of mx and c. Now, this and that will cancel. We'll have y is equal to minus 2x minus 3. Now, you realize now the equation is in the form of y is equals to mx plus c. Now, you can state the gradient because you state and give. Stating is to give or to highlight the gradient. Now, the gradient there is the coefficient of x, and the coefficient of x here is minus 2. And our y-intercept is negative 3. Is negative 3. Lastly, I also want to talk of Roman 3. In Roman 3, I want to give this as an equation that we need to write the gradient and the y-intercept. I can say we have y is equals to 4 plus 6x. Now, this one, you can look at it. It is 4 plus 6x. Now, the question is it written in the form of y is equals to mx plus c before you start stating the gradient and the y-intercept? Now, y-intercept, y is equals to mx plus c. Now, we end up with the constant c. Now, the constant c has already started, so we take it the other side. And as in, we rearrange that equation. We are not taking it, it is not closing the equal sign. The sign only changes when it closes the equal sign. But in this case, it is not closing the equal sign. It is not coming this side. Right? It's only that we want to write it in the form of y is equals to mx plus c, where mx starts, followed by c. In this case, you're going to say y is equal to 6x plus 4. Remember, all these terms that are after the equal sign, they are positive. That's why they have not changed to a negative. Both of them are positive, and they have not closed the equal sign for them to be a negative. So they remain to be the same. It's only the position that has changed. Now, the equation becomes in the form of y is equals to mx plus c, where we can say our gradient is equal to 6 and our y-intercept is equals to positive 4. Now, my beloved student, we are learning on how to state the gradient and the y-intercept. And I've said for you to be in a position to state the gradient and the y-intercept, first the equation must be given. If the equation is given, number 2 thing that you need to find out if that equation is written in the form of y is equals to mx plus c. In the form of y is equals to mx plus c. Now, if the equation is written in the form of y is equals to mx plus c, then the coefficient of x gives us the gradient. The coefficient of x, which is m, gives us the gradient. And remember, when we were dealing with the gradient, we said m is a letter that stands for the gradient, and the c is the y-intercept. C is the y-intercept. And from the examples that I have given on the board, you have realized on how to identify or how to highlight the gradient and the y-intercept. One more thing on this. One more thing on this before I move to the next. One more thing. By calculation. We say by calculation. by calculation, state the y-intercept. The y-intercept by calculation. By calculation. How do you calculate? By calculation, state the y-intercept. Remember, the y-intercept, when you talk about y-intercept, intercept means the equation cuts the y-axis when x is equal to 0. It cuts the y-axis when x is equal to 0. Meaning, at that point where it cuts the y-axis, at that point where it cuts the y-axis, it means x is equal to 0. If I can use my Cartesian plane here, we say this is the x-axis and this is the y-axis. Not drawn to scale. This is not, it's a sketch. Call it a sketch. It's not drawn to scale. It's not drawn to scale. And probably I say that my line or the equation is passing through that point like that. And this is the equation y is equal to mx plus c. Now, remember, our y-intercept is at this point. Y-intercept is at this point where it cuts the y-axis. That's what we call the y-intercept. Meaning, x is equal to 0. When you read this point on the Cartesian plane, let's say this is 2 and this is 4. This is 2, 4, 6. I'm using a scale of 1 centimeter represents 2 units. -2, -4, -2, -4. That is a scale that I'm using as my sketch on the board. Now, if we have to read this point it is 0, 4. This point is 0, 4. Remember, we start with the value of x followed by the value of y. Now, this is the y-intercept. Now, state the gradient by calculation. If you're asked to state the y-intercept by calculation, for example, we say y is equal to 2x plus 4. Y is equal to 2x plus 4. Now, how do you state the y-intercept by calculation? You need to understand it cuts the y-axis when x is equal to 0. It cuts the y-axis when x is equal to 0. So we say when x is equal to 0, what is y? When x is equal to 0, what is y? Now, y is equal to 2x plus 4. X is 0, meaning y is equal to 2 times 0 plus 4. Y is equal to 2 times 0 plus 4. Now, 2 times 0 is 0 plus 4. So, y is equal to 4. Now, in other words, our y-intercept is equal to 4. Now, what did I say? When the equations are written in the form of y is equal to mx plus c, the constant c gives us the y-intercept. The constant c gives us the y-intercept. And by calculation, you've realized that y is equal to 4. Now, you need to know it cuts the y-axis when x is equal to 0. And we've shown you that. Yeah. Now, having talked about those, now, also want to move to touch a little bit on perpendicular lines. Before I give you assignment, before I leave assignment behind, I want to just talk about perpendicular lines. That's the next thing we need to do this morning. I know that you're following me closely. You're with me. Yeah, you're not leaving me alone here. I'm not doing this alone. You are with me. So let's continue. Perpendicular lines. These are lines that bisect at 90 degrees. These are lines that bisect at 90 degrees. The lines that bisect at 90 degrees. Now, these lines, the product of these lines is always -1. The product of these lines is always -1, meaning M1 times M2 is equals to -1, meaning M1 times M2 is equals to -1. But M1 is the gradient. M1 is the gradient of line 1, and M2 becomes the gradient of line 2. M2 is the gradient of line 2, so that you don't worry yourself. What is M1 and what is M2? From the given pair of equations, there must be 2 equations. And then you will be asked to determine if the pair of equations that you are provided with are perpendicular lines. Now, this is the tool. This is the tool that you need to use in determining whether the pair of equations are perpendicular lines. That is one. Number 2, they will also want you to find an equation which is perpendicular to. Those are 2 essential things that you need to have when it comes to the perpendicular lines. Now, let's see this. Let's look at this example. For instance, determine. People say determine, others say determine if the pair of equations given below are perpendicular. Determine the pair of equations given below are perpendicular. We say y is equals to minus 2x plus 4. Then you have y is equals to a half x plus 7. For instance, we say this is a pair of equations. Now we say this is line 1 and this is line 2. Now, line 1 we have the gradient. What is important here is to know how to identify their gradients, of which we've done. Now, how do you state the gradients? For example, what will you say? What is M1? We said M1 is the coefficient of x that gives us the gradient of line 1. Now, the gradient is -2, and the gradient 2, which is M2, is a half. We said for them to be perpendicular, then it means the product of their gradient must be -1. The product of their gradient must be -1. So now our M1 is -2 and our M2 is a half. Now, if you multiply these two, they'll give you -1. Then we say they are perpendicular lines. They are perpendicular lines. Why are they perpendicular lines? Because the product of their gradient is giving us -1. The product of their gradient is -1. Now, you need to identify, or you need to be in a position to state the gradients from the equations for you to carry the next step of multiplying these 2 gradients. So that's why it was very necessary when I was teaching you on how to state the gradient and the y-intercept. More especially at this point, you need to be in a position to state the gradient. After stating the gradient, we are dealing with perpendicular lines. And in perpendicular lines, the product of their gradient must be -1. So that's why we're saying m1 times m2 is equals to -1. Now, Roman 2, what if you are given 2y plus 4x plus 6 is equal to 0? Then you have y is equals to -3x plus 4. Now, we had done this before. I remember using this as an example when I was teaching you on how to write equations in the form of y is equals to mx plus c. Now, you realize you cannot state the gradient. Yes, we are determining on whether if the pair of equations that are given are perpendicular. But you can only do that if you are in a position to state the gradient of the two lines and then multiply them and see if the result is going to be -1. Now, we have to write this equation in the form of y is equals to mx plus c. So we're going to have 2y plus 4x plus 6 is equal to 0. Now, it means 2y is equals to -4x minus 6. I've taken this 2 to the other side. Whenever I take it the other side, it becomes what? A negative. The sign changes from positive to negative. Then divide both sides by 2 by 2. So that this and that will cancel. We have y is minus 2x, then minus 3. Now, this is line 1. Then line 2 is already given in the form of y is equals to mx plus c. Is equals to mx plus c. So it is y is equals to -3x plus 4. Now, whenever these are written in the form of y is equals to mx plus c, it is easy for you now to state the gradients. Now we say our m1 is equals to -2 and our m2 is equals to -3. Remember, if they are perpendicular, then m1 times m2 should give us -1. Now, from the look of things, -2 times -3 is going to give us 6. Now, 6 is not -1. So we say they are not perpendicular. They are not perpendicular lines. They are not perpendicular lines. Why? Because the product of their gradient is not giving us -1. Now, that is the first part of the question that you may be asked in regards to perpendicular lines are concerned. The next part, which is very important, is when they ask you to find an equation which is perpendicular to and passes through the point, which is perpendicular to and passes through a given point. Now, find an equation which is perpendicular to y is equals to -1/2 x plus 4 and passes through the point, let's say 3 and 7. Passes through the point 3 and 7. Now, the first thing you need to realize, there is perpendicular line. And in perpendicular, then we said this becomes the tool to that question. Whenever you see that perpendicular line, the first thing that has to come in your head, in your mind, that the product of the gradient is -1. Now, the equation that you are finding is perpendicular to this, meaning the m1 is already given. The m1 comes from this equation, -1/2 x plus 4. Meaning our m1, we can state it to be -1/2. So we need to find the gradient of the line that we are supposed to find here, the line that they're asking us to find. Find its gradient. And its gradient comes from -1/2 times the m2 gives us -1. Because m1 times m2 is equals to negative 1, meaning we need m2 so that we have the point for us to find the equation. Now, our m2 is going to be negative a half times m2, which is negative a half m2 is equals to negative 1. Negative a half m2 is equals to negative 1. Now, let's multiply both sides by 2 to do away with the fraction. So we remain with negative m2 is equals to negative 2. Divide by the negative so that we do away with the negative. Our m2, that is the gradient of line 2, which we are finding, is positive 2. Negative divided by negative is a positive. Now that we have the gradient of line 2, the line that we are supposed to find, and we have the point where it passes through, that is 3 and 7. Now it is easy to find the equation. We said the equation is in the form of y is equals to mx plus c. Now this is our x and this is our y, because he said points are written in coordinate form. Now 7 is equals to 3 times 2 plus c. Now 7 is equals to 6 plus c. 7 minus 6 is equals to c, and our c is equals to 1. Now it is y is equals to mx plus c, because we have m, which is 2. Now we substitute them here. Now we are going to have y is equals to 2x plus 1. This is the equation that you've been asked to find. Find an equation which is perpendicular to y is equals to negative a half plus x and passes through the point. Now, what drives you to get the answer is the fact that these are perpendicular lines. And in the perpendicular lines, we say the product of their gradients. The product of their gradient is always negative 1. Now, when you know that, and you know how to state the gradient from the equation, it becomes easy to find gradient 1. Now, when you have gradient 1, which is negative half, multiply by the m2. The end result will be negative 1. Now, when you work it out, you find that our gradient of the line that you've been asked to find is 2. And you have been given the point. We go down there where we looked at the point of finding the equation of a straight line, given the gradient and given the point. And that's what I've used to find this. Now, this is the equation. Now, you can go ahead and prove it out if they are perpendicular lines. Y is equals to 2x plus 1, and the other one is y is equals to negative a half x plus 4. These are two equations which are perpendicular. Perpendicular lines, the product of their gradient is equals to negative 1. My time is out, and I beg to stop here. But before I finish, I want to leave you with 3 questions. You add with the question I left earlier before when we started. Now, this is your assignment. Question 1. State the gradient and the y-intercepts of the equations given below. The first question I can give you is y is equals to a half plus 6x. Then number 2, let me give you this one, which you need to make. You have to write it in the form of y is equals to mx plus c, 4y plus 16x plus 24 is equal to 0. Question 2, find an equation which is perpendicular to y is equals to 3x plus 5 and passes through the point let's talk of 6 and 3, through the point 6 and 3. With those few, I want just to wish you a lovely time at home. Stay safe. Follow those procedures. Follow those directives of the government, right? Whenever you're at home, you know, we're going hard times. Wash your hands. Drink water. Warm water, of course. With those few remarks, thank you. God bless you.